So,
Great. Thank you so much, Mark. So if Thomas, if you can now share your slide, and Danielle, if you
yep,
can stop sharing.
good. It remembered where I wanted to share it from. Um, okay, yes, I'm Tom. I'm from the University of Aberdeen, and today I'm going to be talking about the first field day from our summer school. Whilst I may be the one presenting today, I just wanted to acknowledge the astounding effort that my teammates went to create this presentation. So I'm going to be talking about the mixed wave-dominated tidal flat in the Tithonian to Lower Burrasian of the Aguila del Aframba Formation, and hopefully by the end we'll understand the facies and sequence architecture from continuous outcrop in the Teruel province in Spain. So the overall aim of this day was to study a mixed heterogeneous clastic carbonate coastal environment that was influenced by both waves and tides. So we were working in the Gulf subbasin, which is in the western part of the Maestrago Basin. The subbasin was bounded by major extensional faulting, which was generated in association with latest Jurassic to mid-Albian rifting. So you'll see that the Aguila del Aframba Formation contains several erosive unconformities. And in this next slide, we're going to see a stratigraphic column of that formation. So it's composed of heterogeneous clastics, which are denoted by T, mixed heterogeneous carbonates, which are denoted by M, and carbonate facies, which are denoted by C. The vertical stacking of these facies form 8 of the TC sequences, which are known as AG1 to AG8. So each of these sequences is divided into 2 intervals. Firstly, there are the heterogeneous clastic dominated interval, T, and secondly, the carbonated dominated interval. The change from T to C intervals is progressive. That is, that the carbonate content of each sequence increases from the bottom to the top. However, the boundaries between each of the sequences is always a sharp change from C to D intervals, with some local erosional surfaces at the basis of some of the sequences, as we saw in that previous picture. So the heterogeneous intervals included red mudstones and intercalated mixed facies, tabular sandstones, conglomerates, and lenticular cross-bedded sandstones. Locally, continuous packages of pelluridal packstones, grainstones, and fenestral laminated lime mudstones intercalate in both red mudstones and mixed facies. The carbonate intervals have continuous packages of interbedded fenestral laminated and pelluridal facies, intercalated red mudstones, and mixed facies. Lenticular fenestral laminated lime mudstones are also present. We found discrete beds of biatubated bioclastic waxstones. We also recognize packstones in sequences AG5 and AG6. So in the study area, we were also able to recognize different sub-environments and processes. We found tide-influenced fluvial channels, which had lenticular packages of fine to medium quartz sandstones with concave upward base. They had sharp lateral termination, but we didn't find any evidence for biotubation. There was initial channel infill of muddy sandstone clasts eroded from the coastal plain, and then also limestone clasts eroded from storm tides from the coastal areas. There's also a point bar and channel fill. These were tide-influenced fluvial channels with diminished effects of long-lasting fluvial floods. So next, we're going to look at the coastal to intertidal, heterogeneous and mixed facies. They included red mudstones up to 20 meters thick, intercalated decimeter thick beds of tabular sandstones, and decimeter thick beds of mixed facies, including mudstones, marly limestones, and biatubated silty limestones. So the coastal to shallow subtidal carbonate facies. The first of these is the fenestral laminated lime mudstones, which you can see in A and B. These are continuous and discontinuous packages of decimeter thick beds, which change laterally to red mudstones and mixed facies. The fenestral lime mudstones and laminated microbial lime mudstones have local desiccation cracks, dinosaur tracks, and roots. So that was quite exciting. The pure lime mudstones have bioclastic laminae, including small-sized bivalves. We found evidence for algae, some gastropods, ostracods, and forams. The peloidal packstone greystones are in photo C here, which are the second group. These were packages of decimeter-thick beds interbedded with a fenestral laminated lime mudstones with localized red mudstones and mixed facies. Okay, so now we're going to look at the tidal bars. They had a master bedding surface that are roughly horizontal or maybe dip slightly to the west, and internal cross beds with paleo currents, which flow mostly to the south and southeast. It was quite cool to learn how to measure those kind of things, such as paleo currents in a channel. There was evidence for wedge-shaped cross strata and bidirectional paleo currents, and the long axis of the channels were almost parallel to both the tidal current and to the strike of the lateral accretion master surfaces. We found an absence of mud laminae, inclined heterolithic stratification, and a fining upwards trend and biotubation point to the high energy of the ebb and flow of the tides and or the short duration of the slack water periods, with storms contributing to the winnowing of fines. So just going to look at the conglomerates quickly. Here we didn't find, we found rip-up clasts of coastal sediments, which were probably products from tsunamis or storm flows, rather than non-channelized fluvial flows. So sequences 1 to 3 represent deposition in a mixed clastic carbonate coastal mud flat and wave-dominated tidal flat. The key features of sequences 1 to 3 include a well-drained coastal mudflat from the red mudstones, with tide-influenced fluvial channels from the cross-bedded sandstones, and sheet flood deposits, which are shown by the tabular sandstones. There's also a poorly drained coastal mudflat with small ponds and intertidal to shallow subtidal areas. And then finally, an intertidal to shallow subtidal peloidal packstone grainstone indicative of episodic wave dominance. The facies in sequences 4 to 8 allow 2 laterally restricted areas to be defined. Firstly, in the less subsident areas, tectonic uplift generated small incised valleys, which encase tidal bars. Laterally, in a relatively wide and subsident intertidal zone, muddy and heterolithic sediments accumulated. And secondly, we find a mixed clastic carbonate coastal mudflat and wave-dominated tidal flat, which is similar to that which we see in sequences 1 to 3. But here we also find records of local open marine fauna and some oolitic storm beds and subtidal oolitic beds. So that's the main difference as we're moving up the sequence. So this is the correlation of the 3 areas. And what's key to see is the lateral continuity of sequences 1 to 8, which helps achieve one of the aims that we set out to see. And we can also recognize lateral continuity of the facies within the sequences themselves. So in sequences 1 to 3, T and C are laterally continuous. But if we look at sequences 4 to 8, the facies are far more like laterally complicated. So final remarks. There are 2 paleogeographic maps of the main sedimentary sub-environments of the Gulf subbasin for sequences 1 to 3 and 4 to 8. And this allows you to see the changes in the area through time. The tidal influence is recorded in fluvial channels and tidal bars. There's wave storm action indicated by SAM dominance in the tide influence channels and tidal bars, and storm-related sedimentary structures. Subsidence and high rates of sedimentation were key factors controlling the accumulation of carbonates and clastic sediments in tidal areas, and sedimentation kept pace with subsidence so that a general low gradient sedimentary surface was maintained throughout deposition. Yeah, thank you for your attention. And I guess we're leaving questions to the end. Thank you.
Yes, good point. Thanks, Tom. Any questions that you have for the speakers, please wait until the end. We will answer them all at one time so we can have it a bit more streamlined. Daniela, you are up next.
Yes, I'm ready. Pim, pim, pam. Pam, pam. You can see my screen, yes, no?
Not yet.
Okay, now I think yes. Okay.
If you just pop on presenter mode.
Yes, I'll try.
Perfect.
Okay.
Take it away.
Yes, I will switch in presenter view. Okay, I will add. Okay, perfect. So, yeah, good evening to everyone. I'm Daniele, and I'm here to talk about the second day of the IAS Summer School organized by Marcos and Beatriz. I am part of the group 2, which includes Yangxi, Gui, Alejandra, and my man Martin and Chester, and of course myself. The aim of this field trip was to study the oolitic dominated stratigraphic unit that represent a wave dominated coastal platform environment with an infralittoral prograding wedge to see how carbonates behave as a siliciclastic. This field trip is based on Pomar et al. 2015 publication in which Marcos and Beatriz are involved. So just a small geological setting, the field trip was divided into 3 main stops that are more or less located in this map with the red stars. And this area is located in the Iberian Basin, west of Teruel, figure in the bottom right, and allow us to study a wide shallow marine carbonates runs developed during the Kimme region, late Jurassic. During that time, carbonate sedimentation was dominated carbonate sedimentation dominated this part of the basin, fetching the western margin of the Tethys Ocean. The overall Facies distribution show the progradation of the shallow ramp oolitic and the reef Facies of the Posel formation. Sorry for the pronunciation. This formation is around 50 to 70 meters thick carbonate unit, and its age is defined by ammonoid biostratigraphy. The Posel formation in the Sierra de Albarracín consists of dominated oolitic sandstone with minor contribution of other calcareous component and some terrigenous. So just asking with all the Facies, they recognize the 10 Facies from LF1 to LF10 and have been distinguished on the basis of component and sedimentary structure. And this table indicates with this purple color and well, yes, with the red box, the Facies that we visited during the field trip. The relative position of the Facies indicate how an infralittoral prograding wedge system developed. So, yeah, the evolutionary model, the architecture of the sedimentary model is shown in this figure taken from Pomar et al. The deposition model is based on the architecture of the Posel formation and represent how an infralittoral prograding wedge system are developed during carbonate sedimentation. Again, in red, I like in red the 10 lithofacies composing the sedimentary model. During the field trip, we observed the main characteristic of 8 of these, 8 of the 10 sedimentary facies. These lithofacies represent sub-environment above and below the wave base. And yeah, now I will show you the facies observed from the distal one, so LF1, to the proximal ones. So yes, LF1, Mars, and intercalated oolitic sandstone and wakestone. Here the Mars got abundant mica and plant remains and scarce bioclast and are intercalated with fine-grained sandstone to silky limestone. And we got, intense bioturbation. The lithofacies number 2, oolitic packstone and greystone, well sorted 1 millimeters ooids and quartz grain as well. and peloids. We observed also brachiopods, echinoids, and bivalves. And yeah, the bioturbation here is less intense than lithofacies number 1. Then lithofacies number 3, characterized by clino-bedded oolitic grainstone, large scale and low angle, 5 to 10 degrees, clinobeds composed of variable size and moderately sorted oils and other minor components. Yes, lithofacies number 4, true or planar cross-bedded oolitic grainstone, the symmetric to metric thick set composed by variable sized and well-sorted ooids and scarce skeletal and quartz grains. Lithofacies number 5, observed with structureless to poorly laminated oolitic grainstone, the symmetric tabular beds, but structureless. Locally, but locally we observed parallel lamination and some bioturbation. It's similar to the composition of lithofacies number 4. Then the lithofacies number 6, composed by oolitic skeletal grainstone with stromatoporoids, channel-like decimeters, thick beds, stromatoporoids in living position, and oidal matrix and other bioclast fragment. Like gasteropods, bivalves, corals, algae, and foraminifera. Lithofacies number 7, composed by metozoan-dominated mounds, with corals in the left picture, in the stromatoporoids in living position in the center picture, and then in the right one, microbial crust. Last slide observed was the sand intraclastic oolitic paxton and grainstone, intermud facies, the symmetric beds of fine-grained intraclast oolitic sand and Mars, locally rounded skeletal fragment, and occurrence of quartzite pebbles and sand. So some take-home message, facies architecture of the Kimmeridgian Posel formation has been observed in the field. Sedimentological observation allow us the differentiation of 8 lithofacies representing bottom set, pore set, and top set facies from an infralittoral prograding wedge. Yes, the facies architecture and bedding pattern of the Kimmeridgian Posel formation evidence that these 50 to 70 thick oolitic unit conform to the infralittoral prograding wedge model instead of the classic model used. So yeah, we saw how carbonates behave as a silicoclastic in this field trip. And yeah, thank you for your attention. Any question? And yeah, thank you again.
Wonderful, thank you. Victor, you are up next.
Yeah. Can you guys hear me well? I had just a little bit of trouble with my microphone earlier.
Yep, I can hear you great now.
Cool, awesome. All right. Do you guys see that?
Looks perfect. Go ahead.
All right. So, well, good afternoon, everyone. I'm Victor. I'm based at Keele University, and I will present for my group the field trip that we undertook on day 3. So I guess we, instead of describing facies by facies like Tom and Daniel did, we choose rather to like describe every stops in terms of activities and on a more pedagogic way, I'd say. But on day 3, we looked at a homoclinal ramp with microbial patch reefs from roughly the same age that the deposit Daniele talked about, so Upper Kimmeridgian within the Albarracín domain. So in terms of, as I said, in terms of geological setting, we are in that second transgressive regressive sequence stage of the Kimmeridgian. And we're looking at a shallow carbonate ramp at Jabal Uyas. The aim of that day was to characterize the different facies and architectural elements that that are present on that ramp type platform, so basically describing that Facies diversity and architectural element diversity. Then we also try to understand what are the depositional processes that led to these architectures. And finally, we undertook a small exercise to recognize high frequency sequences in the stacking patterns and what factors are controlling these kind of reef growing stages. So just a quick overview of the sedimentological model for the Jabal Oyas formation. There are about 7 carbonate facies distributed from the inner ramp domain to mid-ramp areas. But here for that day, we focused on the patch reef and inter-reef facies, so that's stop number 2 and 3. And as well as a more distal coeval units characterized by bioclastic marley limestone. That's for stop number 4. So for the first stop, we went straight on the outcrop and we looked at massive patch reef with their contemporaneous inter-reef field. So the patch reef is roughly, I'm not going to go into details, but it's roughly a massive structureless metazoan association that kind of build a spatially restricted bioherm. There's also a lot of microbial encrusters community on there, and by looking close up on the outcrop, you can see also some internal cavities within the reef that got filled with very fine material. And like just a few meters next to that, we were seeing these stratified inter-reef infills, mainly composed of pelloidal paxillon and grainstone that kind of were unlapping the massive patch reef. But the key thing here was to first of all describe, that carbonate facies, but also that relationship between these two touching elements. For the step number 2, we looked at the same unit, but rather than on an outcrop, we walked on it literally. So that was a plan view study, I would say, of the same facies association and architectural element. So by walking on it and by looking at a aerial view, you can describe the 2D variations of the spatial extent of these patch reefs. And then we kind of discussed how you could turn that 2D interpretation into a 3D interpretation by using high resolution ground penetration radar analysis. Step 3, we undertook a panoramic interpretation, again of the same unit at a slightly different place. So we did same architectural element description, but also a temporal evolution. We described basically the temporal evolution of that ramp, and we observed 3 sequences with 2 stages per sequences. So stage 1 would be the reef grow, kind of like a keep up regime for a more extensive carbonate platform, reefal platform, And stage B would be a prograding shallow marine calcareous facies that would happen during a sea level fall. And finally, step 4, we looked at the distal equivalent deposit of the Lorry-Gila formation. So same age, different places. We kind of discussed the source of the sediment that we were looking at, because in these distal carbonates, we were seeing unusual bioclastic content in these rhythmic marley limestone intervals. So we kind of discussed about where would these come from? And we finalized today with a little bit of ichnofacies description. So that was a great day. I just want to thank you again, all the staff, for taking us through these outcrop. I guess a key thing that I got from that day was to, while looking at carbonate ramps, you kind of want to keep in mind that you have instead of having a clear, Walter law Facies belt succession, you want to keep in mind that you have a more mosaic-like Facies distribution, which would make sometimes the interpretation a bit less straightforward than in classic pseudoclastic environment. So yeah, that's it for me. Thank you, guys.
Super, great thing to keep in mind, and I like your Beatrice TV star note on the bottom left there. Okay, Chiara, you are up next.
Yep. Can you see my screen?
Yes, but you'll want to pop that. There you go. Awesome, take it away.
So, okay.
Yeah, there we go.
Okay, can you see? Okay. So, hello everybody. I'm Chiara. I'm attending my third year in PhD studies, and today I will doing a short summary of this of the field trip of Team 4, and based on slope ramp with sponge and microbiome mounts from the ocean of Moscardone. This is group 4, Team 4, composed of Enlot, Lucas, Frantic, me, of course, and Carlos and Saikat. And so the aim of this field course was to analyze the Facies architecture of a Bajocian distally steepened ramp that was dominated by siliceous sponges and microbes, and for about 1 kilometer long deposition-oriented exposure. So what we saw was the interaction between internal factors controlling the Facies architecture of this kind of succession. And so what we saw is the colonization of strip floor by microbes and siliceous sponges, and the variation of the storm wave base position with the changing of sea level. So we are in the Bajocian, so in Middle Jurassic, in the central part of the Iberian Basin that was characterized by 2 of subsiding open platform areas. The Moscardone outcrop was located in a Castilla platform here in this geographic map. And this is the outcrop located in this kind of ravine, and we have at least 6 stops. And we start for take a look at the panorama in 4 geographic units, which define 2 transgressive regressive sequences. From 1 to 2, we have the Bajocian unit, the Bajocian sequence, sorry, made up by unit 1 to 2, and then we have the Bajocian 2 sequence made up by units 3 to 4. And these 2 sequences are characterized by the dominance of microbial sponge boundstone and mud supported facies in the lower part, and then in the upper part we have at the top, so in unit 4, the intraclastic bioclastic facies. So here in the lower part we have represented the shallow ramp, so this kind of steeper ramp, the shallow ramp facies made up by intraclastic bioclastic facies, and then the deep ramp where this build up this mound of sponges and microbial occurred. We start from stop 4.2, so we are in the unit 4, and we have this thick sequence made up by coarse to fine-grained intraclastic bioclastic pexton with class made up sponges and intraclass made by macrobial clast, and at the end we have a small amount of microetychoids. And then we have the macrobial encrusted intraclastic bioclastic pexton with micropoloidal microbial crust. So this kind of situation reflects period of high energy alternated with period of low energy. So next we have we moved in the stop 4.3 in unit. We took a look at unit 3 and 4, and we see something new. We saw something new about this situation between unit 3 and 4. So we have erosional surface truncating the upper segment of the slope beds in unit 3, and the consequence, we have erosion and truncation, so top lap of unit 3 into unit 4, when the platform is below the wave base, and while we have incrustations of faces, so on lap of unit 4 into unit 3, when the platform is above the wave base. We have mud supported and macrobial siliceous pond faces kept by a decimeter thick grain supported bed. Here there's a sketch made by Anlot. In stop 4.3, we have some images of these kind of faces, the macrobial siliceous sponge patches. We have sponges, and this faces reflects a decreasing trend in the western thetis in water temperature between 5 to 8 degrees, and furthermore a high concentration of nutrient supply from terrestrial sources. And then we have mud supported faces. At stop moving from stop 4.3 to 4.4, we took a look at the lower unit. So we moved from the top to the lower part. We have unit 1 and 2. So we took close panoramic view in the architecture of the macrobial sponge mouse. So we, in this case, we have macrobial siliceous sponge mouse up to 25 meters thick with progressive thinning toward open mary areas, changing in monotonous succession of mud-supported faces. The main difference between unit 1 and the unit 2 is that unit 2 had the similar characteristic, but is thinner and composed up by 2 high frequency sequence instead of 7 in the unit 1. In the stop 4.4, also we see the position, the architecture of these units, and the position we discussed about the stop of the position of unit 2 because of the lack of accommodation space, and that the growth of both units, so the sponges and macrobial phages, are linked to the nutrient supply controlled by waves or maybe by internal waves. And the last stops was in zone E, is this in the aerial image, in unit 4 again. And here we are a panoramic view of the unit 4. In this case, the unit 4 appear thicker. This is because the more accumulation space. And we took a look at the stratal geometry that were a combination of internal factors and the lowering linkage or the lowering of the sea level. For final remarks, we made a comparison between this kind of the positional system of Moscardon and field trip 3 of Habaloyes. The differences in this case is because in Moscardon we saw on the strike direction, while in the Habaloyes we saw the outcrop in the deep direction. At the end, we saw the macrobial-induced carbon cementation was controlled by the maintenance of the depositional slope, and we have a lot of episodic wave storm reworking, the sediments, and the sponges that control the Facies distribution. Thank you for listening to this presentation.
Thank you, Chiara. Nice job. We will go to our last speaker, Beatrice, one of the organizers of the summer school, and she's going to give some concluding remarks. And finally, after that, we will have some questions.
Okay, Danielle, please, can you show my presentation?
Yes, I'm coming. Just a few moments. Okay. No. Have to. Okay. It's okay.
Thank you. First, I want to thank you, the students, because they have done a very good job in explaining this for field trips. I'm very proud of these students. It's not okay, the screen or the bottom?
I saw this a bit not in well resolution.
Yeah. I don't know why.
Okay.
So let's go. In this summer school, we had, Marcos and I and our assistant, the great opportunity to show the spectacular geology of Teruel, which is a region we have studied and enjoyed many years. But in this course, we were also very lucky because some small, big things that made it so special for us. And these brief conclusions are focused on this. Can you change, please, the next? Next one, please. So sedimentology became easier with those splendid days with almost perfect temperature, the clear skies, so that it wasn't hard to show the Facies correlation. Next slide, please. Here you have an exercise we did with the students. So with this perfect light, it was more easy to help the students to do the correlation of Facies in this case. Also, if you put the next one, please. In this case, in Aguilar de la Alfambra, with these outcrops and perfect light, it was so easy to combine the students that those lenticular bodies were fluvial channels that were encased, intercalated in red mudstone, representing coastal Facies. Can we change to the next, please? As Marcos has said before, we enjoyed a standing place for the afternoon exercise. Next, please. Here you have some images of some exercise we did there. The students made the most of this exercise and enjoy practicing some specific aspects of the field trips we have during the morning. But also we have some kind of gifts. Can you put the next one, please? For example, these sun-kissed coffee breaks and relaxing chats in the backyard of the building. Next, please. We also had some unexpected sections in the course. For example, one day we had to practice our skills in explaining what we're doing there in some TV interviews, in printed and digital newspapers, in the radio, and also in the social media. Next one, please. We had time for enjoying some cultural activities, for example, mainly to admire the architecture of Albarracín and to see the small streets, the castles, the walls, and to enjoy the atmosphere of the city. Next one, please. No, there is a previous one. Okay. Also, we had time to practice the most popular sport in the area, which is climbing. All days we have to practice the beginner level with the stairs in Albarracín. In some field trips, you have to practice the intermediate level to go to the outcrops. And some of the students had the opportunity to practice the advanced one, the grass path climbing, which is very famous in this area. All of these things, the sound, the perfect places, Albarracín, the cultural activities, were like small gifts we had. But the greatest of all the gifts was, next one please, the group of the students. We were very lucky because of this sensational group of students, very clever students, you have noticed with the presentations, and also very charming. Next one, please. From the very beginning, from the first day, we could notice the sincere friendship they had. We only have to check and review our WhatsApp group to notice that they were always ready to help each other. From the beginning of the course, but also, next one please, to the end of the day, but not to the end of the course, because they are still there in the WhatsApp, sharing information and enjoying each other. Next one, please. Well, you know, the students will have great memories of the course. And as you already know, our bus will be ready always to do sedimentology with you. Thank you very much.
A way to wrap all of that. Thank you, Citrus. Okay, so that is now open for anybody to ask any questions. These questions can be scientific, they can be organizational, they can be experiential, if you have questions about somebody's experience. So if all of the speakers can please turn your videos on, we will sort of have everybody ready to answer questions if need be. So our first question is from Yako. Hi, Yako. He wants to know, this is clearly an exciting, highly educational summer school. Could you give the organizers and participants, or can the organizers and participants give any practical tips for future organizers of summer schools? And he is joining us from Bangor, Wales. So I forgot to mention, when you ask a question, if you could please tell us where you're coming from. We'd just like to know where everybody is joining.
Okay, so I answer this,
Yes.
if you like, but because, well, actually the IAS is very concerned on that, and as far as I know, Chelsea knows better than me, because they are preparing a kind of document helping to the future organizers. They ask us for some practical things, but I saw the document, and the document is amazing so far, the version I have seen. And I'm sure that will be really useful to the participants. So there are many things that are in this document. That if I have to tell something special, I don't know. It's yeah. The main thing I think is to create the environment between the people. So make sure you are in a very nice place. The logistics are well done, and of course science. So if you have a nice place, a nice accommodation place, a nice place to stay, and a nice science to show, then you will have success, because people, yeah, the participants for sure will be very motivated, and that I think is the key thing of the course. I don't know. Chelsea.
And that's a great comment. And so for anybody out there who is interested in applying to run a summer school, how that works is essentially you would bring a proposal to the IAS sort of inner management, and we then discuss all of the proposals, and once your summer school is chosen, you will be provided some information, a document that gives, sort of guidelines from the IAS, but also tips from past organizers. And I like that you, Jaakko, actually also asked the participants, because the participants have a very different perspective on what is helpful and what is not. So that's a good point. So I don't know if any of you participants have something specific that you would like to mention for future organizers of summer schools.
I think maybe like a good, I don't know, I feel like we were all very free to do whatever we wanted to do, and it didn't feel like anything like an undergrad field trip or a master degree field trip. Like, we were adults with, like, okay, we're PhD students, but there was it was like a friendly relationship with everyone, and you couldn't tell any hierarchy or anything. And that's, I think, I mean, from my perspective, I guess that's a thing to keep in mind, to keep that good running atmosphere from the beginning to the end.
That's a great point. Okay, so we have a couple other questions, so we'll move on. John Reimer from Amsterdam, hey John, says that he will be visiting a bunch of places, and I'm not going to try and pronounce it, in early February on their way to the south. So he says thanks for providing him with some places to visit and for the informative presentation. So yes, I agree. I think everybody did a great job on presenting the science of the field trip, and also the bookends of the perspective of the greater sort of organization and how you guys went about the field trip. Okay, next question from Khalil. Outstanding presentations, and the summer school looks very organized and way too exciting. Nice job. I have a question regarding the first presentation on the first day of the field trip. Did you find any indications of paleoseismic activity, like some soft sediment deformation structures interpreted as seismites? This would be helpful. This would help deciphering the tectonic controls on the various recognized sequences.
I can't remember if we saw anything in particular like that. We kind of went over a lot of ground in one day, but I'm sure that the staff leading the trip know a lot more about it than I do, and they've probably looked at the beds more closely. So maybe if they know the answer to that.
Mm-hmm. We had the opportunity to see some small faults there are in Aguilar de la Alfambra, but the main feature indicating this faulting is the variation of the thickness of the successions, and also we have these erosion surfaces in the boundary between the different sequences. Probably some beds that are deformed, that are even the conglomerates, could represent this shocking moment, the activity of the tectonics in this rift basin. but there are not clear evidences of big faults. The faults are in the boundary of the basin, but only small faults and this variation of thickness. We don't have anything more.
Okay, great. Our next comment is, he says, thank you, makes sense. Our next comment is from Jaco. Thanks, Marcos. Hope to see some of you in the North Wales Summer School in July 2025. So that's a very good point. For those of you who don't know, especially students, the IAS typically runs summer schools every 1 to 2 years. This year's summer school will be in May, and that will be in the Caribbean, focusing on, it will be in Bonaire, focusing on carbonates. And that round has been closed. So it sounds like a wonderful place. I'm sure it will be a wonderful trip, but no more applications are being accepted for that field trip. The group has been chosen because we're getting close to that, that summer school. But the following summer school will be in 2025 in the summer in Wales, which will also be amazing. And Jaco will be one of the organizers of that trip. So all of you students, be on the lookout, make sure and read the IAS letter that comes out every month. It will give you a bunch of information. Check the website. If you have any questions, you can always reach out to any of the contacts that you find on the IAS website, and we can help get you also involved in one of these wonderful summer schools. So if anybody has any last questions, please type them. Oh, are postdocs eligible? Unfortunately not. No, postdocs would be eligible to participate as an organizer. So as Mark and Beatrice mentioned, Mikel was, I think at the time when you guys started organizing, he was a postdoc, but I think I saw on your slide that he's now an assistant professor.
Yeah. Both Telma and Miquel are professors in the University of Barcelona. Yeah.
Okay. So the organizers can be anybody from a postdoc to a senior PI. So as a postdoc, you can be eligible to participate as an organizer. So if you're interested in something like that, maybe get a team together and submit a proposal. But as a participant, this is mostly for postgraduates, primarily PhD students, but master students are also welcome to apply. That's a good question. Okay, great. So I know we're a little bit over our typical time, so I'm going to stop it there. If anybody has any burning questions, I'm sure any of the participants or the organizers would be happy to answer them, as would I. So you can find my information on the IAS website or the SEDS Online website, and you can shoot me an email with anything that is left unanswered. I want to thank again all of our organizers and participants of this summer school. It was, it seemed quite wonderful. Clearly, you guys did a great job combining sort of, the cultural aspects, the group aspects, and the scientific aspects. Not always an easy thing to do. So congratulations again, and thank you for coming online with SEDS Online today. We will see everybody at our next webinar next month.